If you have a continuous phenomena, you may not get the actual boundaries. But the moment you reclassify that continuous phenomena, it will have a discrete classes, and the moment you have a discrete classes, you will have a boundaries. So it is always good to have a reclassification because it generate a patterns. But the most important thing is it depends what type of on which type of map you are working. So you can reduce the number of classes and eliminate details. And if the input data set itself is the result of a classification, we call it a reclassification. So reclassification data in different systems, or it can be used for different purposes. And you can also assign code based on specific attributes. Now, if you see this, like soil type reclassification, you can reclassify that into the soil suitability classes. And also you can classify your household, like you have a numbers, different incomes, you can segregate them into different high, medium or low categories. So classification, you can generate a reclassification. Vector classification with post processing is required. See, whenever you do classification like a vector classification or a visual classification, you can do a post processing by reclassifying your original codes into new codes. And then you can have a user controlled classification wherein you use a classification table, and then you can also use an automatic classification which we generally do in raster data analysis. Now here you can see that you are basically using reclassification. Here you have the average incomes. They are with different numbers. You can club these your average income into a certain classification, and then you can further reclassify this into this, or you can even reclassify into low, medium or high. So this is very much possible, and you can reduce the heterogeneity of a particular class. So if you just differentiate between the raster and the vector, the topological or the geometric, it will not change if you simply change the attribute, because your topology is not changing. Because if your topology changes, then your entire your original data values will change. So, but in this, if you are simply changing the attributes, you may not change. But if you modify a polygon like containment, area and contiguity, you can simply this thing. But attributes change is not, you don't have to change the topology every time. So that is the one very good thing. And in raster also, because only pixels, attributes are changed. Then in post processing, yes, we do our original data values will change, because what will happen, your original polygon size will change, polygon feature will change, it may become a big polygon, your area will change, your association will change, your connectivity will change, everything will change. So that's why the moment you do a post processing by making use of spatial merging, aggregation or dissolving, your topology will change. And yes, if topology changes, then your vector original data values will also change. So you can see that here there are certain what I am doing, I am just simply merging certain classes, and you can see that the classes has been merged, and we have removed this particular arc, and automatically the topology of this, because the connectivity, adjacency, everything has been changed in this particular phenomenon. So you can see that merging is also changes the actual this thing. Then you can also use a user control classification, wherein you can give different codes, like you can classify, you can club, as I've told you in earlier class also, like in my earlier slides also, like some of the codes like 10, 20, 30, 40, you can club them into a certain category, and you can reclassify them. So that is also that can be called as a user control classification. So here also you can see that you have a continuous phenomena where your elevation grids are with different ranges, but the moment you put them into discrete, like 1, 2, 3, 4, 5, you also get some patterns, and you reduce the detail, and you get the different. So this is mostly common in your raster data sets. So this is also, you can club certain different number of classes into a new class. Now we come to the overlay analysis, which is also very important in this. Now, if you apply any overlay operation on a vector data sets, then your original data values will change. So either it is raster or it is vector. Now if you apply a standard overlay operations, the most important thing is your data should be on top of each other. That is, they should have the same projection and they should sit on top of each other. But the thing is, even if they overlap to certain extent, it can be overlaid. It is not necessary that their extent should be as it is. Their projection should be same and their extent should overlap to some or the other place. So that's then you can do any overlay operation. But if their extent or their projection doesn't match, then it is not possible to do to run a overlay operation. So the principle of spatial overlay is to compare the characteristics of the same location in both data layers and to produce a new output value for each location. So you can see that the most important thing is these maps. You can see the vector overlay, you can see the raster overlay. They all are georeferenced to each other. They all are having the same spatial extent, and they can simply overlay and generate a new polygon which anyway will change their original data values. So if either condition is not met, the use of an overlay operation is senseless. So the most important thing is they should be georeferenced in the same system and overlap in steady area. So that is the most important part in any overlay analysis. So the principle of spatial overlay is to compare characteristics of same location in both data layers and to produce a new output value for each location. So at every point you will have a new polygon with a different attributes. So I may not touch all the operations, but I will touch only few of them which are the part of vector data overlay analysis. To name a few, like union is there, intersection is there, clip is there, overwrite is there. So there are many operations which you can use in order to generate the output on the overlay analysis. But the important thing is this will happen only in point line polygon, because we are only talking about the vector analysis. Now if you see this intersect operation, I am having one input and then I have an intersect data set. So automatically if I intersect, so I will generate an output with this particular thing. Now here you see the most important thing is only the features inside the common area of the two input data are kept in the outputs. That is, the areas which are common to both will be the output. And one input data can be point, line or polygon feature type.